So yesterday we learned the trigonometric ratios. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Remember, you have to memorize those. Now, if we actually want to use those in a real problem to find a side or to find an angle, you've got to figure out which one of the three ratios to use. On last night's homework, it always told you, find the sine of this, find the cosine of that, find the tangent of the other thing. But in these problems, it's not going to tell you, so you have to figure out which one to use. So, let's look at this example. So here we have this 22-degree angle, and we have that it's a right angle. So it's always got to be a right triangle. If it's not a right triangle, you can't do the problem with trigonometry, at least not the trigonometry that you know. There's more stuff that you'll learn, like I said the other day, when you get to pre-cal. But for this class, it's just right triangles, only right triangles. And what we want to do is we want to identify what sides we have in this problem. So this leg that's right next to the 22, what do we call that side? No? What is it we said that you told me yesterday? Adjacent. Yeah. That's the adjacent side. What is 17? Opposite, because it's all the way across the triangle from it. And what is x? Hypotenuse. Remember that opposite and adjacent are both relative to or concerning the 22-degree angle. The hypotenuse is always the one across from the right angle. Okay? So the two that we have are opposite and hypotenuse. Which one of the three ratios has both opposite and hypotenuse? Sine, right? Yeah, I know. It looks like sin. It's hard to look at it and not say sin, but it's sine. So since we know that sine of an angle is the opposite leg over the hypotenuse, that lets me know that I'm going to use sine in order to help me solve this problem. That the sine of 22 will be equal to x, 17 over x. And that's just the setup. We'll talk about solving it in just a minute, but let's practice setting them up first. Because if you can't set it up, then you can't solve it. So for these three, we want to write a proportion for each one of them using a trig ratio. So every time we need to look and see what are the things that we have. I always look to see if I have the hypotenuse first. Do we have the hypotenuse in this one? And number one? Yes. Which side is the hypotenuse? 19. That's the hypotenuse. Then I look to see, do I have the adjacent leg or do I have the opposite leg? Which one is the one that I have here involved in this problem with x? It's adjacent. So, which one of our three ratios has both hypotenuse and adjacent in it? Tangent is opposite over adjacent, which is short for what?
Cosine.
Cosine, thank you very much. Yes, cosine. So this is going to be the cosine of 40 is equal to the adjacent leg, x, over the hypotenuse, 19. All right, for number two, do we have the hypotenuse? Where's the hypotenuse? Where? Yeah, the hypotenuse is down here. Do we know anything about it? No. What side is x relative to the 63-degree angle? It's adjacent. It's right next to it. What side is the 27? Opposite. Which one of our three ratios has adjacent and opposite? Not tran, and not even tan, it is tangent. So the tangent of 63 is equal to the opposite leg, 27, over the adjacent leg, x. All right, for this one, do we know something about the hypotenuse? Which side is the hypotenuse? 34. Then we'll look for the legs. Do we have the opposite leg or the adjacent leg? The opposite, because it's all the way across the triangle. Which one of our three ratios has hypotenuse and opposite in it? Sine. Very good. So it's the sine of 75 is equal to x over 34. All right, before you turn the page, now solve each for x. Okay, before we get too far into this, we need to do a little bit of work with your calculator. So, before we can just start punching buttons, there are two things that we have to do. The first thing, once we do it, we won't ever have to do it again unless you change out the batteries. Okay? We need to make sure your calculator is doing the right kind of angles. There's more than one way to measure an angle. When you get to calculus, you never use degrees again. You use something called radians. Your calculator, if you have never changed it, is probably set to that. So we need to switch out of radians and into degrees. Here's how you do that. Right next to the blue second button is one that says mode. If you have that button, please press it. If you have a different calculator, it may be in a different place, or it may be somewhere else entirely, and I'll help you with that if yours is different. That's fine. We're going to go down to where it says radian. See how radian has the black background on it and it's flashing there? I want it to be on degrees, so I move it over to degrees and hit enter. Now the degree has the black background and is flashing. And then I want to quit out of that. Notice that quit is in blue right over mode. That means you need to press the blue second key first, then the mode, and it'll quit out of that. All right. Does anybody have a calculator that's different? I'm sure there's some. Someone have anything that's different where you're like, I don't know how to get the mode right?
Yeah.
What is yours? It's a Casio? Okay. Casios are great. All right, so right there where it says mode,
Yeah.
you just keep pressing, and yours is already in degrees.
Okay.
So you're good. As long as it has that big D there, you're in good shape. Any others? Okay. So after you set it up, you must do the algebra before you punch it into your calculator. If you don't show me the algebra and something goes wrong when you put it into your calculator, then it's all wrong. I want to give you partial credit. I really do. So let's solve these now. So for this first one, I'm going to put the cosine of 40 over 1 equals x over 19. Now I'm going to just cross multiply. It's a little bit different. I'm going to multiply the 1 times the x, that's x, equals, and I've got cosine of 40 times 19. It's always better if you put that 19 first. You're less likely to make mistakes with your calculator. This is 19 times the cosine of 40. Since x is already by itself, all we need to do is go, okay, 19 times the cosine of, notice it opens a parenthesis. Depending on what calculator you have, some of them make you close it, some of them don't care if you close the parenthesis. It's a good habit to be in to close it, but most calculators, it doesn't hurt if you just leave it. And we're going to round this to the nearest hundredth. It'll be 14.55. Yes. Okay. Oh, you did cosine inverse. 19, you don't have to press second because that's implied. You just do that.
You could even have it in pictures.
Yeah.
4 o'clock.
Okay.
Sociology.
We'll actually use that later
Yeah,
on.
look at that.
I couldn't even study.
Anybody else have any difficulty with that?
What was it?
No, I'm in that class, but it's so boring.
It's actually like
So you type it in just like that, 19 times the cosine of 40. And actually, with TI calculators at least, and I think most other ones, you can leave out the times. You can just do 19 cosine 40 and it automatically understands that you mean to multiply. All right, let's look at the next one. So for this one, let's put the tangent of 63 over 1. This time when we cross multiply, we're going to have x times the tangent of 63 equals 27. Now on the last one, when we cross multiplied, we got the x by itself immediately. Here we got to do one more step. What do we have to do to get rid of this x times tangent of 63 so that it's just x? Divide by. We're going to divide by the tangent of 63. The tangent of 63 is a number. You just don't know what it is. Okay? But it is a number. So that these two cancel out. So in your calculator, you'll do 27 divided by the tangent of 63. And that's 13.76. All right. Now let's do this last one. Again, we'll put this over 1. Is there a question? Okay, don't straight up lie to me. Your mouth was moving and sounds were coming out. Okay? So cross multiply, x times 1 is x equals, I've got sine of 75 times 34 Again, it's better if you'll write the 34 first. So 34 times the sine of 75. So it's 34 sine of 75. And you get x is 32.84. Before we go on to the next page, let me just show you real quick, if everyone will watch for a moment. Why is it better to put the 34 first? Yeah. If you do sine 75 and you forget to close it and you do times 34, it's going to give you a completely different number. You can put it last, but then you absolutely have to close the parentheses first. So if you put it at the front, you don't have to worry so much about closing the parentheses. Okay? Yeah, you're exactly right. All right, let's go on to the next page. So let's solve these. All right, someone tell me, what sides do I have on this one? Got the opposite, yep. And what else? No. So you have to be really careful. Adjacent means the adjacent leg. Okay, you're right that it's adjacent, but it's not the adjacent leg. Okay? So it's across the right angle, so this is the hypotenuse. All right, somebody else tell me, which ratio are we going to use? Is it going to be sine, cosine, or tangent?
Sine.
It's going to be sine. Sine of what? What is the angle?
28.
Sine of 28. It's always sine or cosine or tangent of whatever the angle is. Now, sometime next week, we'll do ones where we don't know what the angle is, and we'll put an x there. Okay? Equals. Opposite is 27. Over the hypotenuse is x. So again, sine is opposite over hypotenuse. We'll put this over 1 and cross multiply. We'll get x times the sine of 28 equals 27. What do we do to solve that? Exactly right. Perfect. Divide by the sine of 28. So it's 27 divided by the sine of 28 is 57.51. All right, on this one, which sides do we have? Opposite? Which side is opposite? X is opposite. And what side is 47? It's the adjacent. Which one of our three ratios, is it sine or cosine or tangent, that has adjacent and opposite? Tangent. So tangent of the angle, 72, equals the ratio of the opposite leg, x, to the adjacent leg, 47. We'll put this over 1 and cross multiply. We get x is equal to 47 times the tangent of 72. So it's 144.65. Okay. Everybody try number 3 on your own, please. If you get stuck, feel free to talk to someone sitting near you. All right, let's see how you're doing on this. So, Andres, what are the 2 sides that I have?
The adjacent and hypotenuse.
Yep, 68 is the adjacent, and x is the hypotenuse. Blake, can you tell me how to set up the equation?
It's going to be sine.
Not if it's adjacent.
Oh. Oh, it's right? I don't know.
It's what? Cosine.
Cosine.
Cosine of what?
31
Mm-hmm.
over 1.
Yep.
And then x over 68. Or 68 over x.
It's 68 over x. It's adjacent over hypotenuse. All right, now we'll cross multiply. We'll have x times the cosine of 31 is 68. So I'll divide both sides by the cosine of 31. And we get 79.33, yes? All right. Before we go, and I'd let you get started on your assignment, let me point something out. Let's say that I knew it was cosine and I set it up wrong. Okay? Don't copy this down, please. Let's say that you did cosine of 31 is x over 68. If you cross multiply, you get x is equal to 68 cosine of 31. And let's see, 68 cosine 31. Oh, hang on a second. Accidentally hit an extra key. You get 58.29. So let's say I didn't have the 79.33. I want you to think back about things we did earlier this year. How do I know that can't be the right answer? Yes, ma'am. It has to be just. It has to be more than the 68. That's exactly right. If you will look at your answer and think about it a little bit, sometimes you can be like, okay, I know that this is not right. Now, What happens if you're, pressed for time on a test and you're like, I don't have time to fix this, but I know that it's wrong. Okay? If you want me to give you at least some credit, right? I know this is wrong, but I don't have time. Move on. Okay? It'd be better if you had the time to fix it, but if you don't, you're like, yeah, this can't be right. The other thing is, let's go to this one. We got that this was 144.65, right? What if I had gotten that this was like 32? How do I know that's not right? How do I know this is not 32? Well, if this is 72, this angle, subtracting from 90, is 28. The bigger the opposite angle is, the bigger the side is. Remember, the biggest side is across from the biggest angle, and the smallest side is across from the smallest angle. Here's the smallest angle. If I got that this was 33, 47 wouldn't be the smallest side. The smallest side and the smallest angle have to be across from each other. And if I got this is 47 and that's 33, I know that 33 can't be right. Okay? So you can spend literally a couple of seconds on each problem going, is that a reasonable answer or not? All right, your assignment is in the book. You can go ahead and get started on that.